Hi friends, in today's video I am going to discuss about the cylindrical coordinate system, which is also known as the rho phi z coordinate system. Basically, in case of the cylindrical coordinate system, the parameters are rho phi and z. Okay, I have already discussed the Cartesian coordinate system in my last two videos. So if you haven't watched my last two videos, so please do watch those videos first. After that you can come to the cylindrical coordinate system. That will be easy to understand this portion. And also one more thing, that is I have put the link of the total playlist in the description, so please do check it out. Now coming back to the point, cylindrical coordinate system, that is also called the rho phi z coordinate system. Now at the beginning of the coordinate system I have shown you the positional vector, right? That is nothing but a generalized positional vector or position vector, and whose parameters are u, v and w. In case of the Cartesian coordinate system, the parameters u, v, w, that is the parameter of the three-dimensional vector space, was given by x, y and z. And similarly, just like as a Cartesian coordinate system, the coordinates u, v and w has been represented by rho, phi and z. Okay, right. So I will write this over here. In case of the cylindrical coordinate system, the parameters u, v and w, that has been represented by rho, phi and z. Now as the parameters u, v, w has been represented by rho, phi and z, then I can also write the positional vector in case of the cylindrical coordinate system. Now what is the positional vector in case of the cylindrical coordinate system? Now in normal way or in the generalized portion, I have shown you that the positional vector had the three directions u, v and w. In this case, or in the case of the cylindrical coordinate system, the positional vector has the three values along with the three directions rho, phi and z. What are those? That is nothing but the arrow in the direction of rho plus a phi in the direction of phi, and the last one is az in the direction of z. Okay. Now this is the positional vector in case of the cylindrical coordinate system, and this was the important one also. This is the positional vector of the cylindrical coordinate system. Now I think you can easily visualize what I am trying to do by just comparing the Cartesian coordinate system and the cylindrical coordinate system. Yes, you are right. Now I am trying to draw the actual cylindrical coordinate system in the three-dimensional vector space. Now let us see how it looks like. See, this is the actual cylindrical coordinate system in the three-dimensional vector space. Don't worry, I will make you understand it and every point. See, first of all, look at this. X, look at this x, y and z. This is a three-dimensional vector space, and inside the three-dimensional vector space, as I am considering the cylindrical coordinate system, that's why I have considered a cylinder. Okay, right? So I have considered a cylinder, and in that cylinder I am considering a small portion or the small part of that cylinder, that is the orange color that has been shown here by the orange color, right? Why I have considering this orange colored portion? Because I am only trying to do analysis in the positive x, y and z direction. Now considering positive x, y and z direction, what is the portion of the cylinder that we can see? That is nothing but this portion that has been shown here by the orange color. Right. That's why I'm not considering the total cylinder over here, but I'm considering this orange colored portion. And on this orange colored portion, I'll do the further analysis. Now, look at this cylindrical shape very well. Above this cylinder, I'm considering a point P over here. I think the point P is clearly visible. So as the point P is over here, that means I can say there is a particular distance between the z-axis and the point P, and also above the xy plane. Above the xy plane, the point is at a particular height, just like as the cylinder. Okay, and that's why I can write these two parameters as first parameter is, that is the distance of the point P from the z plane, or better to say, that is the perpendicular distance of the point P above the z plane, sorry, z axis, right? Let us consider this distance as rho. So this is a rho distance. Okay, this distance is rho. Now this is rho. This is the rho one. I am not overwriting here, but I think you can understood the what is the rho. Now I have understood the rho. Now the height of the point P, the height of the point P above the xy plane. Say this is denoted by z, right? This is denoted by z. Also, this one is also z. Then, okay, right. Let me write it clearly. And z means, that is I am denoting it by small z. That is the height of the point P has been denoted by small z. Okay. I think it will be very much confusing. So let me write it like this by an arrow. And this is the rho and this is the z. And this is I have told about rho and z. The remaining parameter, that is the phi. Now see what is the phi actually. The phi is nothing but the angle. Phi is nothing but the angle from this exact plane. That means this is the phi. Angle produced the point P from this exact plane. That is the phi. That means I am considering at x phi is equal to 0 degree. Okay. At x phi is equal to 0 degree, and also at y phi is equal to what? At y phi is equal to 90 degree. Okay. So that means what is the phi actually? Phi is nothing but the angle produced by the point, depending upon, produced by the point above the x-axis or the x plane. Okay. That is the phi. Right? I think you have now understood what is rho, phi and z. So basically in this direction, as we move from x-axis in this direction, means phi is increasing. Phi is increasing. Okay. Now I have told the rho, phi z And not only that, this point P, this is not a normal point. It must have some direction also because it is a positional vector, right? So as it must have some direction, so let me show you the directions also. Definitely the directions will be along the direction of the rho, phi and z only. So first direction is like this. The second one is like this. The third one is like this. Now this is the direction of rho. So that's why I am writing here a rho. This is in the direction of the phi. If you look at the phi carefully, this is the direction of the phi. Okay, right? And this is the direction of the z. So that's why I am writing here az. Basically, direction is denoted by the unit vector. I have already told you, right? So as point P is a vector or the point vector or the positional vector, it must have some directions and definitely three directions along the direction of rho, phi and z respectively. Now the interesting fact that here you can also see that what the angle between all these three is 90 degree. Okay, right? All these three is what 90 degree. So for from here I can write one more important thing, that is a rho, a phi and az are orthogonal. Orthogonal means it definitely obeys the RH curl rule. Sorry, this is orthogonal. Means obeys what? RH curl rule. This is an important thing that you have to remember. Okay. And it is seen here also. These three are the orthogonal. Now let me discuss the parameters rho, phi and z in detail. Okay, just like as how we discussed about the x, y and z, let me discuss the rho, phi and z also. So first let us see what is the rho. Let us see what is the rho. Now rho is very much simple. What is the rho? You can see from z axis the perpendicular distance between the p and the z axis is nothing but the rho, right? So that's why I am writing here what is rho. Rho is nothing but perpendicular distance between point P and z axis. That is the rho. Now what is the range of the rho? See, rho is starting at here, right? At the center point, at the z axis. And from the z axis, it is going to up to infinity. So I can write the range of the rho is very simple. Just by looking at the diagram, you can write that is 0 to infinity. From 0 to infinity, it is going actually. Now, what is 0? 0 means at the z-axis. At the z-axis, the value of the rho is 0. As we move the p, as we move this point p towards more, or as we increase the radius of this cylindrical shape, then the distance between the z-axis and the point P, that is the rho, will be more and more. So it can go up to what? It can go up to infinite. Okay, that's why the range of the rho is nothing but infinite. Okay, now this was all about rho. So now let us see what is the phi. Okay. Now this is the phi. Phi. What is the phi? I have already told you what is the phi. Phi is nothing but the angle made. You can see the phi angle has been made above the xy plane, right? The angle phi has been made above what? Above the xy plane. Now the phi is the angle on the xy plane made by the point P, made by the point P with respect to the x-axis, right? Above the xy plane, due to the point P, the angle made between x-axis and the plane of the point P, that is nothing but the phi. So phi is, I can write, the angle made in the xy plane with respect to what? X-axis, due to the point P, because the angle has been made due to the presence of the point P, so that's why I have written over here. Okay, now coming back to the range of the phi. Now understand the range of the phi very clearly. Here I am trying to make a cylinder, right? Now what is the phi is equal to 0? That is the point. This is the point at where the phi is equal to 0 actually. Now if I try to make a cylinder, I have to move the phi from 0 to complete one revolution. Now complete one revolution means that is the 2 pi. I have to move phi from 0 to complete one revolution. That means the range of the phi will be starting at the 0 degree and it will go up to 2 pi. That is the 360 degree. Then only we can make a cylinder, right? So that's why to make a cylinder, the range of the phi should have 0 to 2 pi. The range of the phi will be 0 to 2 pi. That I will write over here, right? That is the 0 degree to 2 pi, right? That is the range of the phi. I think you have understood this. Now I am not considering the green, I am not considering this orange colored portion. I am considering now the total cylinder right now. Okay. Basically, for analysis purpose only, I have drawn the small cut. I have done a small cut over this violet colored cylinder. That is the orange color portion. That is for only for the analysis purpose, right? But considering the total cylinder, range of the phi will be from 0 to 2 pi. Okay. Now coming back to the last parameter, that is the z. What is the z? Let us see the z, which is a simpler one. Z. Z. Z is what? Look at the portion clearly. What is Z? What is this Z? Z is nothing but the height of that point P, right? Z is nothing but the height of that point P, and this height above what? Above xy plane. The height above the xy plane for that point P. Or you can also say that is the distance between point P and the xy plane. Right. So that's what I am writing over here. What is the Z? Z is nothing but perpendicular distance of P above the xy plane. That is actually Z. Now, can you tell me what is the range of the Z? Yeah, which is also very easy. That is, just visualize this thing. Now, what is the range of the Z? The range of the Z is nothing but the range of the height of the cylinder. That is nothing but minus infinity to plus infinity, as we have also seen the in case of the Cartesian coordinate system. In case of Cartesian coordinate system, all of these three parameters x, y, and z all were from minus infinity to plus infinity. For this case also the z will be minus infinity to plus infinity, because the cylindrical shape will maintain. Whatever the height will be, the cylindrical shape will be maintained. The shape of the cylinder will not change, right? So height may be minus infinity to plus infinity. That's what the range of the z will be also, right? So that's why let us write the range of the z from minus infinity to plus infinity. Okay, yeah, it's clear. I think it's clear, right? Now I think you have understood what is this rho phi z in this case, this cylindrical coordinate system. What are these rho phi and z actually? Okay. Now I will try to make a note over here that I have also written above. That is the note. Note is important one. The note is, in case of the cylindrical coordinate system, whatever I have already told you, this arrow, a phi and az, that is the three direction vector for the point P. That is arrow, a phi, az in the direction of rho, phi and z respectively. Those are orthogonal, right? That means they obey the R rule. That's what I am writing over here. That is a rho orthogonal to a phi orthogonal to a z and obeys RH curl rule. Now, according to the RH curl rule, what will happen in this case? So let me draw the right hand first. Just a minute. Let me draw the three arrows of arrow, a phi and a z. These are the three arrows. These are the three arrows in case of the array curl rule, and the three arrows were what? One was a row. This was what? This was the A5, and this was the A Z. This was right. You can see there is the row, phi, and Z. These are the three arrows. And definitely each of them are orthogonal with each other. So that's why I can write this as, I can say that a row cross a phi according to the array curl rule equal to what? A row cross a phi equal to what? That is nothing but the AZ. Similarly, a phi cross AZ, that will be a row. I'm sorry, this will be row, right? And AZ cross a row, it will be a phi. Okay. And one more thing that I want to mention over here, don't try to change this a row and a phi positions. Row phi or Z phi or Z row. This position, don't try to change it, otherwise the direction will be reversed. That means if you write the a row cross a phi, that will be minus Z direction. Very important. Most of the students again do the mistakes here, that is they think that a row cross a phi, that is equal to a phi cross a row. That's not like that actually. This is the cross product, not the dot product. If this was the dot product, then the both will be same, right? But in case of the cross product, the direction reverses. Similarly, this happens here, and arrow cross is it, that will be nothing but the a phi. Okay. These are the orthogonal to each other. Very important thing that I want to mention over here. I have mentioned that. Right. This is the important one. Let me bracket it. Okay. So that's all about the basics of the cylindrical coordinate system. In my next part, I will discuss about the differential length, area, and volume, just like as a Cartesian coordinate system. Right. That's all about for now. Hope we will meet you soon in my next video. Thanks for watching.